Okay, I don't know if I can zoom in. I'm just going to step up. I'm going to zoom in on this little bit of work that I did here. It's really hard to see. I'm going to have to go back. Lower the camera down. Going right in for a shot. Right there. Turn on the light, we should be rolling. This is what you guys over in Europe, I want you to build this. So I'm not going to be in the picture. This is a 10-gallon hot water space heater, and from the ones that I've seen in the past, the ones that use a wood boiler external of the house, and this will do the same thing, but it'd be an internal heater. You could probably adapt it to your wall, or just put put the exhaust out your chimney. But basically, you got a truck radiator. Ones that I've seen, they were truck radiators, but they weren't. I think a radiator out of an 18-wheeler or a diesel truck is going to be more superior and be able to handle it. And so you're talking about a large capacity truck rad, maybe double core. If you do use conventional 3/4 ton truck rad, maybe get one with a double core. So it has a large capacity flow, so it's actually going to extract more of the heat out of the water. So you're looking at, when this is operational, you should be able to heat between 1,200 to 1,500 square feet at the cost of about 2 ounces, I'll say 2 to 3 ounces of propane per hour. And your fan air, this is your JoePipe here. This would be like an 1.25 inch JoePipe. I'm going to change rulers here. Going into a plenum. So this is your heat tube here. So what you're doing, you're creating the exhaust of the JoePipe, and that's going into an enclosed plenum. So it's going to reduce the exhaust heat from about 2,000 degrees, and time that it's absorbed in the plenum might reduce down to about 500 degrees. I've done this with a 4-inch diameter by 5-foot stainless steel pipe, and I was able to get the outside up to around 500 degrees. That's why I'm saying 500 degrees, because I've already seen it in a working model. So the heat's being pumped in so this heat in here, this whole 3-inch plenum, that's going to be about 3 feet across, 3-inch diameter. That's a large. You have a very large exchange of your heating element heating up your water. You got lots of surface area. That's what you want. You're going to be able to heat up this. It's probably a 7-gallon capacity here. Your box would be maybe. So your rad could be 3 feet square, so this would be roughly maybe 8 by 10 or something like that. 8 by 10 by at least 24. You can make it 24 long, and say 8-inch square or 10-inch square, depending on what capacity that you want. But if you had 8 to 10 inches, like just a square water plenum, that you'd be able to mount a truck radiator on top. And of course, you would put that into a whole thing into a sleeve, and you would have your 2 twin electric fans in behind to drive the room air through the radiator to exchange the heat. And you could actually do an advanced model where the heat coming out of the front of the van, you could capture that, and you could vent that up into your furnace. So if you've got a furnace, you can generate your hot water on demand heat, and you could port the heat directly into your furnace. So your cost of operation will be around 2 to 3 ounces per hour to keep this tube at 500 degrees. You're still going to have plenty of exhaust heat coming out of the end. So you'll be able to use that maybe for cooking or personal hot water. I divided this into 2 plenums, one for heating water to the truck rad and one for personal, or maybe for an auxiliary hot water. So maybe it might be best just to use the whole thing as the supply for the truck rad and go from there. That way you'll be able to, you might have to reduce the size of your Joe pipe. So when you reduce the size of your Joe pipe, it's going to use less fuel. You don't want the Joe pipe to be too big, and you don't want to use the 3-inch pipe as a Joe pipe, because it's going to take more fuel, and it's this water, you won't be able to stop it from steaming, because the Joe pipe is extremely hot. It's very, very efficient way of converting propane or natural gas into very, very, very high heat. So there's a very high efficiency rate. So you're using 2 to 3 ounces of propane or natural gas, and you're converting that into heat inside the plenum to be absorbed by the water. That keeps this radiator going. So as the fan's driving out the heat, exchanging the heat, you probably have to have this on turned to low, and she's going to run fine. So you're looking at about a 10-gallon unit, maybe more. I'm not sure what those big truck rads holds, what the capacities are, and I figure no more than maybe 7 gallons here. 7 gallons here and about maybe 3 gallons in the rad. I'm going to get back to you on this. We got company. You're going to have to cut this short.